Hey students, we are doing paper May June 2024, paper 4 variant 3. So we are doing paper 43 from the year 2024 in May June. The previous questions are done in the previous videos, so you can watch the previous videos for those questions. We are starting with question number 6 and then we'll do question number 7. So question number 6 is, this question is about iron. Figure shows a blast furnace used to extract iron from its ore. So as you can see in the diagram, the waste gases are given off from here. The molten iron is going out from the bottom pipe. And here in the blast furnace, we have added the raw materials, which is coke, iron ore, and limestone. Name the main ore of iron used in the blast furnace, which is hematite. Then name the substance that enters the blast furnace at A. So in the A, something enters into the blast furnace as the name is indicating the blast. So a blast of hot air enters from A. Name the reducing agent in the extraction of iron in the blast furnace. The reducing agent is carbon monoxide. Carbon monoxide is the main reducing agent in the blast furnace because the iron oxide which is present in the ore, in the hematite, the iron oxide which is present, it gets reduced by carbon monoxide. Carbon monoxide takes oxygen from it and forms carbon dioxide, and this iron will come out, iron oxide. From the iron oxide, the iron will come out and it will be extracted. So carbon monoxide is the main reducing agent. Explain why limestone is added to the blast furnace. Give details of the chemical reaction that are involved. So why the limestone is added? Now, first of all, what is limestone? Limestone is calcium carbonate. Why we're adding calcium carbonate in the blast furnace? The first reason is we add calcium carbonate to remove impurity. To remove impurity present in the hematite, and the impurity is silicon oxide. The main impurity is silicon oxide. So we remove silicon oxide by using limestone. How do we do it? The thermal decomposition happens first. Thermal decomposition of calcium carbonate. The equation for this reaction is calcium carbonate decomposes into calcium oxide and carbon dioxide. Now this calcium oxide, number 3, this calcium oxide reacts with the silicon oxide, which is an impurity, and forms calcium silicate. Calcium silicate is a slag and is removed in the molten form from the bottom. So calcium oxide, we have to describe it also. Calcium oxide reacts with silicon oxide to form slag. The list shows the properties of some elements. So the elements act as a catalyst. They have low densities, low melting boiling points. Some of the elements form acidic, some form basic oxides. They form colored compounds. They form positive or negative ions. These are some of the properties. Now, iron is a transition metal. Sodium is group 1 metal. State which property from the list is true for sodium but not for iron. True for sodium, low density, because sodium is in group 1 and group 1 metals are softer as compared to transition elements. They are hard. So sodium has low density. Also, we can write low melting points. as compared to iron. Which property is true for iron but not for sodium? The property which is true for iron is that it can act as catalysts, or we can also write that it forms colored compounds. These properties are not shown by group 1 elements. Which property is true for both sodium and iron? The property which is true for both is that these are metals and they form positive ions. Both form positive ions. Or we can also write that both can form basic oxides because they are metals. Metals always form basic oxides. Then which property is not true for sodium and not true for iron? So, not true, we can write the opposite of these two, that they form negative ions, which is not true for both. They form negative ions and they cannot form acidic oxides. Next part, steel consists mainly of iron. Steel is an alloy which mainly consists of iron. Iron rusts when it reacts with water and oxygen. Figure shows magnesium blocks attached to the bottom of the steel boat. The magnesium does not completely cover the steel. The magnesium blocks provide sacrificial protection for the steel. Now, as you can see in the diagram, this is a steel boat and it has some magnesium blocks attached. So it is not completely covered with magnesium blocks, just few blocks are attached somewhere. But these magnesium blocks protect steel from rusting. Explain in terms of electrons why magnesium is used for sacrificial protection. First thing, point number 1, you will write that because the magnesium is more reactive than iron, magnesium, because in sacrificial protection, always that element is used which is more reactive than iron. Number 2, in terms of electrons, we'll write that magnesium loses its electrons in preference to iron. Because as magnesium is more reactive, so the more reactive elements have more tendency to lose the electron. Magnesium also loses 2 electrons to get 2 plus charge, and iron also loses 2 electrons to get 2 plus. Both of them are metals. But the difference is that magnesium is more reactive and iron is less reactive. More reactive means that it has the tendency to lose electrons easier than iron. So the iron loses its electrons later, or if the magnesium is present, then magnesium will lose its electrons and react with oxygen instead of iron. It protects the iron from rusting. Name a metal that cannot provide sacrificial protection for steel. So, any metal which has low reactivity than iron. Low reactivity than iron. Because in sacrificial protection, only the more reactive metals can be used. So here we can write copper or silver, or you can even write gold because they all have less reactivity than copper. Next, we have question number 7. Many organic compounds contain carbon and hydrogen only. An organic compound A has the following composition by mass. We have the percentage of carbon and we have the percentage of hydrogen. Calculate the empirical formula of compound A. To calculate the empirical formula, we have a series of steps which we have to follow. Carbon and hydrogen, these are the two elements present in the compound. For carbon, the mass is 83.33, and for hydrogen, it's 16.67. We have to find their number of moles. This is the first step. We'll find their number of moles. For carbon, we'll divide it with their molar mass or atomic mass. Carbon divide 83.33 divided by 1, and hydrogen 16.67 divided by 1 by 12. Sorry, carbon 12 and hydrogen by 1, which makes carbon as 6.94 and hydrogen 16.67. Now to find the whole number ratio, we have to divide by the least number. Here, the least number is 6.94. So we'll divide both of them by 6.94, which makes carbon 1 and hydrogen 2.4. Now, as hydrogen is 2.4, it's not a whole number. It's not a whole number, so we have to multiply both of these numbers with any number so that we can get a whole number. We can multiply it by 5. And when we multiply 2.4 by 5, we get a whole number. So for carbon, we will get 5. And for hydrogen, we'll get 12. So the empirical formula of this compound will be C5H12. Compound B has the empirical formula C2H5. This is the empirical formula of another compound. The relative molecular mass is 53. Determine the molecular formula of compound B. Now, the empirical formula is given to us, and they're asking us to find the molecular formula of the compound. To find the molecular formula of the compound, we will multiply this empirical formula with any number n. This number can be any whole number. We will multiply the empirical formula with n. Now, first of all, we need to find n. To find n, we have to divide the molecular mass by the empirical formula mass. Empirical formula mass. The molecular mass is given in the question, which is 58. And empirical formula mass we can calculate. Empirical formula is C2H5. If we find out its mass, it will be 12 into 2 for carbon. And for hydrogen, it's 1 into 5. So basically, it will be 24 plus 5, making it 29. So 58 divided by 29 is 2. We'll multiply this 2 with the empirical formula, which is C2H5. We can get the answer. It is C4H10. B. Figure shows the section of a polymer formed from an alkene. Identify the functional group in alkenes. The functional group in alkenes is carbon-carbon double bond. Now we have the section of the polymer here. Draw the displayed formula of the monomer that forms this polymer. To identify that what is the monomer of this polymer, we have to see the repeating unit. As we can clearly see in the diagram that this thing, which contains carbon-carbon, is repeating itself here. So it means this is the repeating unit. So to make the displayed formula of the monomer, we just have to close the side bonds and make a double bond between carbon-carbon. Rest of the things will remain the same. So it will be carbon, double bond, carbon. At the top, it will be C2H5 and H. On the second carbon, it will be H and H. This is the monomer which forms the above polymer. Name the monomer used to form this polymer. Now we have to name this monomer. To name the monomer, what we can do, we'll give the numbers to carbon. So it is 1, 2, and here we have 2 carbons. If we make its open structure, it will be like this. Carbon double bond carbon, it is having 2 hydrogens. The second carbon, it has 1 hydrogen and then C2H5 attached with it. So this thing over here, this is representing C2H5, which is written in the combined form here. So this one is 1, 2, 3, 4. On 1 carbon, there is double bond attached. So, and there are 4 carbons total. So it will be but 1 ene. Alkenes are produced by cracking alkanes. When C12H26 is cracked, the products are ethene and an alkane which forms in a 2:1 mole ratio. Write a symbol equation for this reaction. Okay, now as they are saying that the ratio will be 2:1, it means one of the product is ethene, which is C2H4, and the ratio here is 2:1. Means 2 molecules of ethene, and then there is 1 molecule of the other product. So here we can count the carbon numbers 4 and hydrogen atoms will be 8 in 2 molecules of ethene. So here in the product we have 12 carbon. So we can do 12 minus 4. It comes out to be 8. So it will be C8. And for hydrogen, it's 26 minus 8, which comes out to be 18. So H18. Whatever we get here, the carbon numbers, the total carbon numbers and the total hydrogen numbers which we get, we will minus these numbers with the reactant carbon and hydrogens. And we can get our answer. This is 2:1. 2 molecules of ethene and 1 molecule of the other substance. This is also, this is alkane and the name is octane. Next, draw the displayed formula. Okay, state the general formula of alcohols. For alcohols, the general formula is CnH2n plus 1 OH. Draw the displayed formula of one alcohol with the molecular formula C3H8O. Name the alcohol you have drawn. So, this is an alcohol with this formula C3H8O, and it is having 3 carbon atoms. So we can make 3 carbon in a row. 1, 2, 3. With any carbon, we can attach OH, because here they have not written that we attach it on first carbon or the last carbon. So we can do it. We can draw it anywhere. Then we'll complete the rest of the valency of carbon with hydrogen atoms. This is propanol. And because on the 1 carbon, the OH is attached, 1, 2, 3. So we'll write it as propane 1, O. For this one, because they have not mentioned that which alcohol will draw, we can draw propane 2-ol also. This will also be considered correct. We can do like this. And we can attach this OH on the second carbon. And when we attach the OH on the second carbon, it will become propane 2-ol. Both answers are considered correct. The paper is complete. You can watch the rest of the videos to complete the previous questions from this paper. Thank you.